I'm going to talk about bias now. Bias is going to be you have your population and you have your sample. So we have our population, we have our sample. And bias is going to be something that's going to cause the sample to give a different answer than the population. It doesn't mean that it's right or wrong. So if most of the population believes that baby puppies should be shot or something, and the population believes that, and the sample finds that baby puppies should be shot, then that's not a bad sample. I mean, it's bad people possibly, but the sample is giving the same answer as the population. So bias is something that causes the sample to give a different answer than the population. And we're going to break up sampling bias. There's going to be sample bias. There's going to be non-response bias. There's going to be response bias. And there's going to be measurement bias, which I'm going to kind of subdivide into general measurement bias, leading questions, and loaded questions. So there's going to be sample, non-response, response, and 3 types of measurement biases. So we'll start with a sample bias. So a sample bias, sample bias. A sample bias occurs when the sample doesn't necessarily reflect the population. So for example, if I wanted to know, do people generally like math, and I do the survey in a 12U math class, I might find that people generally like math. If I take the survey over in, I don't know, a grade 12 history class, you might find a different number. And it doesn't mean that the history people are wrong or that the math people in the math class are correct, but the sample's different, right? And so the sample doesn't necessarily reflect the population. Let's say I wanted to know, should we give more money to football or the arts program? And I did the survey among the stands at a football game. I might find that people were more supportive of the football program than of the arts program. And again, it's not that the people are wrong or that the people are lying, it's that because I've chosen my sample poorly, the sample doesn't reflect the population. So for example, people often, and it's actually very common, like sample bias occurs the most when people do convenience samples, because usually what's convenient is people who are most like us. So for example, if I did a survey on how many people have graduated university, I might find that almost everybody I know has graduated university because the people I tend to hang around with have graduated university. And I might find that a lot of them are teachers as well. Go figure. Or not. Maybe I don't like teachers. But the point is that a sample bias is when the sample does not reflect the population. The best way to avoid a sample bias is to probably do a stratified sample, as we discussed in the other lesson. So as long as you stratify the population accordingly, you should be able to avoid a lot of the sample bias that may occur. Next, we're going to have a non-response bias. So non-response bias is you have a survey, and some people answer. So these people answer your survey, and these miscreants do not answer. And that's always going to happen. And that's not necessarily a problem, right? So you have some people, whenever people do a survey, be it online or by cell phone or by whatever means pollsters do to attract a response, some people will answer, some people will not answer. You have a non-response bias when the people who do not answer are different in some meaningful way than the people who answer. So for example, if I did a survey, how many people own a home landline? So let's say I find out how many people did a home landline, and I did a survey by calling people on their landlines to find out how many of them have a home landline. Obviously, it's a little ridiculous, but I'm trying to be ridiculous. So in that case, the people who have a landline, the people who don't respond, are generally those who do not have a home landline. And the people who do respond are people who do have a home landline. So the people who respond are different in some meaningful way than the people who do not respond. There's a lot of reasons that people might not respond also, right? A lot of surveys, there are large demographics of people that get missed by surveys. Students tend to get missed by a lot of surveys because they move around a lot, so they don't have a stable contact address. People living in situations of poverty tend to not be part of it. So, I mean, if you have a survey and let's say you're calling cell phones, the people who don't have cell phones might, so the non-responders who don't have cell phones might be different in some way than the people who do have cell phones. And that's a non-response bias. There was a controversy a few years ago where so we have a census in Canada every 4 years. A census is when they ask everybody in the population. And they have something called a long-form census. So most people do a short census. So not most. Everybody's supposed to do the short census. And then a few people are randomly selected to do the long census. And it's mandatory. You must do it. And the reason they make it mandatory is to avoid the non-response bias. So what happened was, though, some people don't like filling out the long-form survey. They found it very intrusive. And so there was a government that decided to make it optional. And they said, okay, we're going to make it optional, but we're going to give it to more people. And there was an issue with that because it didn't, when you allow people not to respond, the people who were not responding were those who had a general mistrust of the government, and they might have different answers than people who did respond. So it created a non-response bias into something that previously had a very low non-response bias. And surveying more people, right? So if you have your sample and then respond and don't respond, but you make your sample bigger, so the government proposed, okay, we're just going to make the sample bigger, you still have the same problem. You have the people who are not responding are different than the people who are responding. And so that was a non-response bias. It's actually pretty hard to avoid a non-response bias. When they do surveys, they often, if they have to get a sample of 200 and it takes them 10,000 tries to get those 200 people, it means that the validity of that survey might be called into question because they've had so many people not responding, and there might be something significant about these people who are not responding. The problem is, of course, that you don't know anything about the people who are not responding. So there's no information there. Next, we have response bias. So response bias is when somebody lies. So they have a reason to lie. So for example, let's say I put out a survey and I said, how am I as a teacher from a scale of 1 to 10? So teacher skills from 1 to 10. And I said, send an email to me with your name attached to it. And I might find that I get some really high marks. Why? Because you have a reason to lie, because you might be worried that I would adjust your mark. I wouldn't, but it's a pretty reasonable fear. I actually had a professor in university once who did that. He handed out these surveys on his teaching quality, and he walked around as we filled it out. And I couldn't stand him, but I still gave him great marks because, I had reason to lie. I was nervous about his ability to remain impartial. Let's say you do a survey on how many people beat their kids. You might find that the answer is very low. Why? Because people would probably not admit to it. They might get in trouble. And even if they wouldn't get into trouble, people tend to respond to surveys in ways that they feel are socially acceptable. So if people if they say, how many times do you lie per day? How many lies per day? People will lie about it. They will, and they're not necessarily trying to be malicious, but they'll undercount it because they know that you're not supposed to lie, and it sounds better if you don't lie. So that would be a response bias. Okay, and the last one is a measurement bias. So in a measurement bias, that's when the very act of measuring changes the answer. the book actually is a good example of this. So let's say I stood outside of Mayfield and I measured the speed of the cars going by. And as you may or may not recall, it's a 40-kilometer-an-hour zone right outside of Mayfield. And if I was sitting there measuring it with my radar gun, I don't know how radar guns look, but I might find that the average speed down Mayfield is something like 70 kilometers an hour, something like that, roughly, give or take. Now let's say instead, right, a cop stands there in full uniform. I don't know how to draw a cop hat, but let's pretend it's a cop hat. Right, and he's measuring speeds. He might find that the average speed along Mayfield is something like 38 kilometers an hour. And why is it lower when the cop measures it? Because the very act of the cop standing there and measuring it changes the answer. That's common in other things too. It's common in, say, if you take a food diary. I'm not sure how many of you have been asked to keep a food diary, but the very act of measuring what food you take in tends to change the type of food that you take in. You may not want to write down that you... So if you lied, let's say I had my big bag of chips and I just didn't write down that I had the bag of chips because that's embarrassing. That would be a response bias. I'm not talking about that. I'm talking about a measurement bias. What I might say is I might say, okay, I don't really feel like writing down chips in my food diary that I'm about to hand in to somebody who's going to judge me. So instead I'm going to have vegetables because, you know, they're healthy and I'm awesome. So the very act of keeping a food diary changes the thing that it's supposed to measure. And that might be a desirable result or not a desirable result, but it can happen. There's a saying, I forget how it goes exactly, but it's any tool that you use to measure something becomes invalid as a tool because people game it. I'll try to find the actual quote for you guys another time. I forget it right now. So that's the first part of measurement bias. That's what I call general measurement bias. Then there's different types of measurement. The actual questions might cause problems. So for example, I might say you could have something like something called a loaded question. So a loaded question might be where I really want. I'm trying to, like, for example, if I said, do you support burying nuclear waste near the water supply that will kill your kids? Right? Do you support it? Yes, I support killing kids. No, I don't support killing kids. And right, so it's the Kill Kids survey. And I might be like, well, no, I don't really support burying nuclear waste, so no. If I changed the question, I said, do you support burying nuclear waste in a safe area to keep our population safe? You might be like, yeah, I'm okay with that. And a loaded question essentially guides you to the answer. Not more than guides; it kind of forces you to the answer. The idea is that it is kind of a gun to your head. If you don't answer in the right way, then there's something wrong with you. You screwed up in some way, right? Do you support raising the already crippling high taxes? Well, obviously not. They're crippling high. Do you support raising taxes that are so much lower than they were 40 years ago? Well, yeah, because I do, because it's so much lower now. So that's a loaded question. It's where the question itself tells you what the answer should be. And the last thing is kind of a leading question. So a leading question is going to be one that guides you to an answer. So let's say I say, how many calories do you eat in a given day? And then my answers are 0 to 100, 100 to 200, 200 to 300, and 300 plus. The answer, by the way, just off the screen. The answer, by the way, is we pretty much all eat more than 300 calories. But let's say you didn't know that. A lot of people don't want to look stupid, and they don't really know how many calories they eat. And so they would probably pick one of the middle ones and say, yeah, that sounds about right. So a leading question kind of guides you towards some answers, right? How many times have you cheated on your schoolwork? And then they might give you a range. Or it could even be, it doesn't have to always be ranges. There's other ways of having leading questions. I could say, what's your favorite movie of all time? So it could be Inception, Starship Troopers, Hello Kitty, Happy Island, I don't know. Or other. Now let's say there's a really great movie. What's a really great movie? Of course, I'm drawing a blank. But let's say, for example, that The Dark Knight was actually a great movie. It actually was. But let's agree that it's a great movie. What's more likely to win, one of these three or Dark Knight? And the answer is that one of these three is more likely to win because we've provided them as an answer. So one of these three is much more likely to win than The Dark Knight because we haven't given it out for special consideration. And the correct answer, in case you're wondering, is Starship Troopers, best movie ever. And that's bias. Again, the bias is something that's going to cause the sample to give a different answer than the population.